Active and passive elements. So active elements means it is capable of delivering energy independently for an infinite duration of time. So that means a source can able to deliver energy independently for an infinite duration of time interval. So it can able to supply energy to some external device over an infinite time interval. So that is called active elements. So we can see the examples of voltage source, current source, transistor, operational amplifier. So these are all the sources can able to supply energy to some external devices for an infinite duration of time. So that is called active elements. So next one is passive elements. So passive elements and the examples for passive element is resistance, capacitor, inductor and transformer. So these are all the devices which cannot be able to deliver the energy independently for an infinite duration. Or we can say it is not it can't able to supply an average power to some external devices over an infinite time interval. So these elements or passive elements it is not able to deliver energy independently by its own. These elements can able to for example these elements either dissipate energy in the form of heat or store energy. So these elements can able to dissipate energy or store energy, but it does not supply any energy independently for infinite duration. Coming to the resistance, the function of resistor is dissipate energy in the form of heat. L means inductance. So inductance, the function of inductance is it can able to store energy in the form of magnetic field. Coming to the capacitor, it can able to store energy in the form of electric field. So these are all the functions of passive elements. So the main difference between active element and passive elements are active elements can able to supply energy independently. So we can take the examples of voltage source, current source, transistor, operational amplifier. Passive elements not able to deliver energy independently. It just store the energy or dissipate the energy. So the examples are resistor, capacitor, inductor, transformers. So next one is lumped element. So lumped elements are physical size of elements which are very small when compared to the wavelength of the electromagnetic wave propagation. So lumped elements means we can say for example you can take a resistor, capacitor, inductor. The physical size of the elements are very small when compared to the wavelength of the electromagnetic wave propagation, right? And these elements, these resistor, capacitor, inductance can be electrically separable. We know that voltage divider rule and current divider rule, and we can by using series and parallel connections we can separate the resistance and connect the resistor, right? So these elements are electrically separable. So lumped elements means the physical size of the element is very small when compared to the wavelength of the electromagnetic wave propagation and which are electrically separable. So next one is distributive elements. So distributive elements means the physical size of the element is very large and we can't able to do electrically separable. For example, transmission line. So you all know transmission line is very larger in size. The physical size of the transmission line is very large and we can't able to do electrically separable like resistor and capacitor. So that is called distributed elements. So distributed elements means physical size of the element is very large and which are not electrically separable. The example is transmission line. Bilateral elements. A circuit whose properties remain same in either direction of operation. So that is called bilateral elements. You can take the example of resistor, inductance, capacitance. In this resistance, if we connect from positive to negative or negative to positive, the operation of the resistor does not change. It remains same in both the directions, and also in inductance, capacitance. And you can take it is positive or negative, or it is positive to negative. We can connect in whatever direction we can connect. The properties are same. It does not change in both the direction. That is called bilateral elements. So bilateral elements means in a circuit whose properties remains same in either direction of operation. That is called bilateral elements. Next one is unilateral elements. Unilateral element means the properties does not same in both type of directions. For example, you can take a diode. The positive side can be called as anode, negative side can be called as cathode. If we connect from positive to negative, that is anode to cathode, means it acts as resistance or voltage drop. Suppose we connect from negative to positive, the current flows from negative to, that is cathode to anode, it acts as open circuit. So it can perform two different types of function in both the directions. So the properties changes in either direction of operation. That is called unilateral elements. So unilateral elements means, in suppose if we connect from positive to negative and negative to positive, it can perform different types of operations. The properties changes in both the directions. That is called unilateral. Okay, so mostly for a diode, current flows only from anode to cathode. So that is called unilateral elements. Linear and non-linear elements. Linear element. An element is said to be linear if it satisfies the linear voltage to current relationship. That is called linear element. So linear element means the element should satisfy the linear operation. That is, the voltage to current relationship should be linear. That is called linear element. The relation between V and I, that is voltage and current, is linear. The current passing through a resistor is proportional to the voltage applied. So current is proportional to voltage. Voltage is proportional to current. That is called linear operation. Any element which satisfies the linear property can be called as linear element. Next one is non-linear element. Non-linear element means all elements which do not satisfy the linear voltage to current relationship. That is called non-linear elements. So in this non-linear element, it does not satisfy the voltage to current linear relationship. That is called linear element, non-linear elements.